And I'm live. That is cool. And today is 8th of August, 2025, Friday. And yesterday was allegedly 7th of August. And yesterday was a Code Forces contest in which I performed terribly. And I am not satisfied with my performance yesterday. I could have done better, much, much better. But the main thing that I have taken away from yesterday's contest is that I have to be calm, or anyone who is solving a problem has to be very calm and patient and think clearly while solving the problem. That is the main thing that I have taken away from yesterday's contest, that I have to be calm. Calmness is very important, and I do not have to be anxious while solving a problem. And my main focus should not be speed, because still I am in a learning stage. So my main focus should not be speed, but instead it should be getting the problem right and making sure that I understand all the parameters that have been provided and what is the freedom that the problem offers, what is the space that the problem offers in which I can roam around and do experiments and get to the right answer. That is one of the main things that I have taken away from yesterday's contest. Calmness. I have to be calm. And second is that I will not be always at my best. Sometimes it will be bad and I won't be able to get the solution even when I have the competence and ability to get it right. And thus, my rating does not perfectly reflect my competence. And therefore, when it goes down, I do not have to beat myself to the hammer with it. And I do not have to be very sad. Instead, I have to think about regrouping, re-strategizing, and getting back at it, because setbacks will be there, because the goal that I'm trying to achieve is very hard. 2000 rating for me, it is very hard. So these setbacks are going to be a part of it, and I will have many of these setbacks. So if my main strategy is, whenever I face a setback, to just beat myself with a hammer and tell myself that I am the worst human being and I have no skills and nothing, I cannot do anything in my life. If that is my strategy, then I won't be able to get to 2000, which is my goal for this year. So I have to be very calm, patient, and do not beat myself to the death whenever I have a setback. And that said, I was looking at what is P and NP's problem, and I thought it would be very hard, but I understand it a bit. I was watching Lex Friedman's interview with Richard Karp, and I I want to explain what I understand from it. So, yep, YouTube knows that I'm live. Cool. There are already viewers. So, P versus NP problem, that is what I want to explain, and it is not as difficult to understand as I thought. So, P, that is an amazing P. P versus, wait a minute, NP. And what does this mean? P and NP, these are sets. P is a set which contains some problems, a lot of problems, right? Let's call them P1, P2, P3, and a lot of problems are in this set P. And NP is also a set which also has a lot of problems, P1, P2, P3. And we know for sure, after you understand what kind of problems are in the P set and what kind of problems are in the NP set, after you understand them, you will understand that P is a subset of NP. And the whole debate is whether P set equals NP. That is, every problem that is in the NP set, is it also in the P set? What we know right now is that every problem that is in the P set is in the NP set. We know that for sure. But we want to know, is the reverse also true? Every problem in the NP set, is it also in the P set? And what are these problems? In the P set, P simply means like P simply means polynomial. So P, I'm very sure that the spelling is wrong. Polynomial. P is the subset, is a set that contains algorithms, that contains problems which have a polynomial time algorithm for them, like problem of sorting. We have, let's say, bubble sort. Bubble sort can sort any given data of size n in time big O of n square. And since here sorting is the problem and bubble sort is the algorithm, and for this problem the algorithm has a time complexity of n square, and n square is a polynomial time complexity. Therefore we can add the problem of sorting into the P set. And what is a polynomial time complexity? Anything, if your data is of size n, then anything in the form of n power m plus n power something m minus 1 and like a b dot 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 till n power 0, anything of time complexity like this is a polynomial time complexity. And when you add it in asymptotic notation, you rip away everything else and you will only have the highest power of m. So any algorithm whose time complexity is n square, n cube, n4, stuff like that, every algorithm like that is polynomial time algorithm. So every problem whose solution algorithm can run in polynomial time, that those problems are in the P set. That is the P set. And what is the NP set? NP stands for polynomial. Makes sense. And NP is also a set. And what does that contain? NP means non-deterministic. Yeah, spelling is like wrong somewhere, I guess here. Non-deterministic polynomial. And this is also a set. And what does this contain? There are problems whose algorithm we do not know, but given a solution, we can verify if this solution is correct or not. And for example, sorting again, you have a problem of sorting in which, let's say, you have been given some data of size n, and someone has given you a solution for this sorting problem for this particular data. And let's say this is the solution that they have given you. So in n time, you just have to go through all of these data points once and you can verify if this solution is correct or not. And that will take you O of n time to verify, not to find the answer, but to verify that the given answer is correct or not for this problem. And that takes polynomial time. So all the problems whose solution can be verified in polynomial time come in the set of NP. Like you can determine in polynomial time whether the given solution is correct or not. So sorting is a problem whose solution can be verified in polynomial time if it is correct or not, and sorting is also a problem whose algorithm can run in polynomial time to find a solution. So P concerns itself with algorithm to find the solution, and NP concerns itself to checking whether a given solution is correct or not. And another example for some problem that is in NP is Sudoku. Given a solution for a Sudoku puzzle, you can verify just going through it a couple of times whether the solution is correct or not. So Sudoku is also in NP, but I do not know for sure. Do we have a is Sudoku in P? No, Sudoku is generalized and not in P. So this means that we do not have a constant, we do not have a polynomial time algorithm which can solve a given Sudoku problem. But we do have an algorithm which can verify whether a given solution is correct or not. So that is cool. So now we have a set P and a set NP. P are the problems whose solution can be found in polynomial time, and NP is the set of problems given a solution we can verify if this solution is correct or not. So if there is some problem in P, that is whose solution we can find in polynomial time, then we can also definitely verify if that solution is correct or not in polynomial time. So every problem that is in P is also in NP. But the question is that every problem which is in NP, that is who's given a solution for which can we verify that the solution is correct or not in polynomial time? Is that problem is in P or not? Like Sudoku. For Sudoku, we can figure out if the given solution is correct or not in polynomial time. But the question is it also in P? Can we also find the solution for Sudoku in constant time or not, in polynomial time or not? And like this must have been very hard when people first understood it, but something amazing happened in 1971. Apart from India-China war, India-Bangladesh independence thing, uh, in 1971, a man named Stephen Cook, he published a paper, and in that paper, he took the problem of satisfiability. What is the problem of satisfiability? In discrete logic, in propositional logic, we have some binary expression. Let's say, okay, am I going to explain all of this? Okay, in propositional logic, you have equations. For example, in normal integral logic or in any number theory, in any mathematical equation, you have questions like this. X plus y equals 2x, and then you figure out, are there values of x which satisfy this equation, or values of x and y which satisfy this equation? And in this case, yes, there are, where x equal to y, every number will satisfy this equation if we take x and y equal, right? And the freedom in choice of numbers in normal mathematical equation is any real number, which could be 1, 2, 0, minus 10.1 pi, any real number, rational, irrational, integer, negative, positive, any real number. But when you are concerned with propositional logic, in that you have, let's say, the same equation, x plus y, but you do not have operators like plus or multiply or minus. In propositional logic, your operators are and, or, not, and XOR, like binary operators. You have binary operators, and for any given variable, you could either choose them to be true or false, which are generally represented by 0 and 1. 0 represents false and 1 represents true in normal notation. So whenever you have an equation like this, let's say x or y, I'm representing or with this x or y. Here we are asking when will this expression be true, and this would be true if you have either x equal to 1 or y equal to 1. If you have any of these, then this expression would be true. So we have found a solution for this expression in which this expression yields true, and therefore we can classify this expression as satisfiable. Yeah, satisfiable. I do not have to write the whole thing. This problem can be classified as, this expression can be classified as satisfiable. And what is the satisfiability problem then? The satisfiability problem is given some function of some variables x, y, z dot dot something, and this expression is Boolean, that is, it has binary operations like and or not, and the variables that have been provided, this or any variable that has been provided, they are binary variables, that is they can only take 0 or 1 value. And the problem of satisfiability is, can you find a particular set of values for x, y, or all of these variables which would make this expression true? And a nice example would be this. Let's say you have a function, a Boolean expression, in which you have x or y and x not x or y and x or not y and not x or not y. So this is a expression, Boolean expression, which takes in two, which takes in two input, x and y. And in this expression, no matter what you do, you will never find values of x and y which makes this expression true. And we can go through this. X can only have 0 and 1, and y could also have 0 and 1, and we here have four possibilities. X is 0, and I messed up below here 1. Yep. So we have four possibilities. When x is 0, you could say choose y equal to 0 or y equals 1, and when x is 1, you could choose y equals 0 or y equal to 1. And we can create a table, a Boolean table of sorts. And let's say for x equal to 0 and y also equal to 0, what will this thing yield? What be will this be true or false? When x equal to 0, so this is false, both of these will be false because not, this is an OR operation, and this is false, this is false, therefore this thing will be false, and we are only taking and for a and to be true, everything has to be true, but this here is false, therefore this will result in false, so this is not a solution. So if we go with x equals to 0 and y equals to 1, then in this one, in this expression, x is false, and since y is true, therefore not y will be false, therefore this whole expression, this whole sub expression will be false, and since we only have ands on both sides, this whole expression would be false, so this results in false, and this is also not a solution. And similarly, for x equal to 1 and y equal to 0, for x equal to 1 and y equal to 0, this thing would be false, which would make the whole expression false. So this is also not a solution. And similarly, for x equal to 1 and y equal to 1, we would have this expression to be false, and this would make everything false. The whole thing would be false. So this is also not a solution. And at this point, we have gone through all the possible combinations of x and y, and we have not found a single solution. Therefore, this expression is not satisfiable, and that is the satisfiability problem. Given a expression, a Boolean expression, you have to find if it is satisfiable or not for some given values of x and y. And here it is not satisfiable. And what Mr. Stephen Cook proved in his 1971 problem, and yes, before that, given a Boolean expression, if someone hands you a solution for it, um, which is or the combinations of zeros and ones that the person has chosen a solution for it, then you can go through the expression and put those values in the expression and see if that expression is satisfiable or not with those given values, if that expression, Boolean expression, is true or not for those given values. So, and we can do that in polynomial time. Therefore, satisfiability is an NP problem, right? Like we have different NP problems. We have sorting is a NP problem. Given a solution, you can verify in polynomial time if this is the correct solution or not. And we have Sudoku as an NP problem. Given a solution, you can figure out in constant time algorithm if the given solution is correct or not. And similarly, we have satisfiability as an NP problem. Given a solution, you put those values in the Boolean expression and figure out if this is the correct solution or not in polynomial time. So at this point, what do we have? We have a set of problems called P, which I want to be white. Yep, racist stuff. P, and we have a set of problems NP. And in P, we have problems like sorting and stuff. And in NP, we have problems like sorting, Sudoku, and satisfiability. Just any normal problem. And in 1971, Mr. Cook, Stephen Cook, proved that every problem that is in NP can be translated into the satisfiability problem. What this means is that every problem in sorting in NP can be translated into a satisfiability problem. And what this means is that you have a set of rules for every problem in NP. That is, for a sorting problem, you have every element A0, A1, A2, and yes, that is A, not 0. You have, this is your rule for sorting. If you are sorting in non-descending order, this is your rule. Every next element has to be greater than or equal to the last element. So Stephen Cook said that every problem that is in NP like this, these set of rules can be converted into a satisfiability problem. And yes, you just have to take his word because I'm not very smart to understand what he said and how that is true. So I cannot explain it because I myself do not understand how you can convert any NP problem into a satisfiability problem. But what we can think about is the implications of this, which means that every problem in NP, no matter how hard or simple, you can convert that into a satisfiability problem. And now we have satisfiability problem. It is, we already know, a part of NP set, and since every problem in the NP class can be converted into a satisfiability problem, we can call the satisfiability problem NP complete, which means any problem that is NP complete, it has to pass two things, that the problem itself has to be an NP problem, and second, that any NP problem could be converted into that problem. And here we have satisfiability problem. It is a part of NP problems, NP class, and also any NP problem can be converted into a satisfiability problem. What this means is the implications are that satisfiability problem is as hard as any other NP problem. And what this means is that if you find a constant time algorithm for the satisfiability problem, that would make the satisfiability problem a P problem, a polynomial time problem. It would make, and since any problem can be converted into a satisfiability problem, therefore we have a bridge, the satisfiability problem, which is a NP complete problem. You can convert any NP problem into a satisfiability problem, and since allegedly you have figured out an algorithm to solve the satisfiability problem in polynomial time, therefore any NP problem would be completed in polynomial time, which would make NP equal to P, and that is the whole debate. And since 1971, people have figured out different NP complete problems, and for a problem to be NP complete, it has to be in the NP subset, and any other NP problem could be translated into this. So satisfiability was our first NP complete problem, and since then people have figured out or found different NP complete problems. And the whole thing is that now if you were to prove any, at least even one of these NP complete problem, a part of the P class, that is, find a polynomial time algorithm to solve any of these NP complete problems, then you would be able to solve any NP problem in polynomial time, and that is crazy. And I heard what Richard Karp said about this. He thinks NP does not equal P. That is his view. And Donald Knuth, the guy who invented the asymptotic notation, he said that even if we somehow proved that NP equal to P, even if we prove that, it would not help, because even though the algorithm to solve any NP problem would have polynomial time, the algorithm itself would be very, very complex and incomprehensible for us humans. So it might not help us, because even though the algorithm is polynomial, the complexity of the algorithm would be very high for us humans to even comprehend. So that would not help us a lot. And I just wanted to get it out there. This is amazing. I thought N equals NP and versus NP is very hard, but no, it is not very hard. And yeah, I understood it, I guess. Bro, how to do yesterday E? Uh, Yesterday is E. What is this? I could only do till D. Shit, I only did two questions yesterday. Bravo, bravo. There was a two set question of core forces way back. Two set? Okay. It is very rare. What is satisfiability question? Okay, I guess. Yeah, this was P versus NP. Raw. And now about yesterday's contest. Yesterday's contest was, I'm not very satisfied with my performance in yesterday's contest. I only did, I was only able to do A and B. I couldn't do C and D. Like D is like 2000 level. I'm currently at 1300. So I could make an excuse and say that C was above my pay grade. But for A and B, I'm satisfied with my performance in A. I did it in 8 minutes and that is fine. That is fine. I can improve it over time. And but with B was not that hard. The main problem that caused me to take more time was that I panicked and I was trying to get the solve the problems as fast as possible, and that is a mistake. I shouldn't have done that. I should have kept my calm, because when I did keep my calm, I was able to solve it. I did lose rating in yesterday's contest, 10 rating points. And one more thing, that for these 3 months, August, September, and October, my main focus is on learning and not on my rating, because if I work very hard and learn a lot of things, then I can get to 2000 in just 2 months after giving contests. But the main thing is I have to learn. So for the first 3 months, my main focus should be on learning, and I guess that should be the way that you go about things. And now off to the problems. Contest 141041. A. This one was fine. I did this one in 8 minutes, and 8 minutes is very average. 8 minutes is not too high. Yeah, it is fine. I can improve that over time. So in this problem, you have an array A of n non-negative integers. However, some elements from A are missing and they are represented by -1. And we define that A is good if and only if the following property holds for every I like this. So max of any three consecutive numbers should be equal to the maximum of those three numbers minus the minimum of those three numbers. And max is the smallest number in a given array, which is not a part of the array. And I have to determine whether I can convert this given array, which has some numbers and some negative numbers, minus ones, which represent missing numbers, into a good array or not. And in this thing, the main thing that I had to realize, what you have to realize, is that if max equals 0, that means in your array, in your given array, you do not have a 0, which means you have at least 1, right? You have to have, which means you do not have a 0 in your array. And therefore, since you want your maximum minus minimum equal to max, so you would want your maximum to be equal to your minimum for their difference to be 0, which would mean all of these three consecutive numbers whose maximum and minimum you are taking, they have to be same for their max to be 0. Therefore, they have to be same. Yep. And since your max is 0, it means that your max, that 0 is not among these three numbers, which means you could have any positive number here instead of 0. And if your max is not equal to 0, then at least one of these elements is equal to 0. and then your minimum would be 0, and you have to have a maximum, and then you would have to have your maximum should be equal to your max, but that would not be the case, because let's say you have 1 as one of the numbers here, then 1 would be your maximum, and your max would not be 1, because you have already 0 and now you have added a 1. So the smallest number that is not in the array is 2, so this would not be true. Let's say then you have 2, let's say, in this array somewhere. So now you have 0 and 2 as two of the elements among these three. Then your max would be 1, and 2 minus 0, the minimum element, is not equal to 1. Therefore, you will not have it. So your max has to be equal to 0. Only then you can make this array good. And if your max is 0, then you want all the elements in your array to be equal for the difference of the maximum and minimum to be equal to 0. And what this means is that when you have missing numbers, you can replace them with any positive integer except 0, as 0 is not a positive integer. You can replace these numbers with any positive integers and make this a good array. In this, you can make all of these minus ones into 1, and that would be true. And here, for these three elements, your max is 0, and the difference between the maximum and the minimum is also 0. So cool. In this, also cool. In this, your mix, like the same thing that I explained above, your mix is 3 here, and the difference between the maximum and the minimum is 1. So that is not cool. So this is no. This cannot be converted into a good array. And also in this, so what you want is all these elements in the array to be equal to some element, but that number cannot be equal to 0. And in this, you have 5 and you have a 1. You have two different numbers, and that is not acceptable. So for this also we have no. And then here, since we have a 0, that is not cool. We want all of these numbers to be same, and we can convert these minus ones into 0, but there are two conditions. First, we want all of these numbers to be equal to each other, and second, that they cannot be equal to 0. So we can make these equal, but they would be equal to 0. So that is also false. No. And in this, you have two ones, and you can convert these minus ones into a 1, and all these numbers would be equal to 1, and they would be equal to each other. So that is cool. You can do this. Yes, and in my solution that I wrote, that is what I did. I first do this, take in the n, then take in the array of numbers, and then diff. By diff, I am representing the first number that is not equal to -1. The number that is not equal to -1, which means the number that I will be making all the other numbers equal to. And then I take in the input, and after that, I am traversing through the array. And for every element, I'm checking if it is not equal to -1. If it is equal to -1, I can just change it to any number I want. But if it is not equal to -1, then I see, is my diff equal to -1? That is this the first time that I'm seeing a different number? And if it is, then put diff equal to x, the number that is different. And else, if it is not, if it this if I have already seen a number that is not equal to -1, then I will check that this non-1 number, is it equal to the same non-1 number that I saw before? And if it is not, then it is not possible. P equal to false and break. And here I will see if P equal to false, either that or diff equal to 0, that I have seen a number that is different, but that was equal to 0. So in both the cases, I output no, and otherwise the answer is yes. And I got it right. Like yesterday I got it right, and in the morning I saw someone else's solution, um, and I submitted this again, and just to see how things work. Yo, if you are aware, can you talk more about incompleteness or I've heard about Russell's paradox and incompleteness. Yes, the incompleteness in mathematics, that mathematics is incomplete, and about Gödel's proof, Gödel, 1931. Yes, I would like to talk about it, and I would have yes, shit, Gödel's incompleteness. Yes, yeah, I would like to read about it more and like do stuff in it. Bro, I'm in class 10th and have no clue what it is. That is no problem. A few months ago, I had no clue what this is. Bro, please tell what it is. I am so curious about it. About this. This is competitive programming. And the thing that I was talking about at the start of the stream, it was P versus NP, which is like I explained it in the start of the stream. I'm so curious. Yes. Can you please tell me? So it is because I want to be a programmer. I want to take Mac in future branch. Yeah, you can take Mac. That is cool. And this is competitive programming. And in competitive programming, you have contests. And yesterday was a contest. And in a contest, if you go there to a contest, you get problems like this. Problem number A, problem number B, C, D, H. And A is the simplest, and they rise in difficulty from top to bottom. And you go to a problem, you read the question, you see that you will get an input like this, and you have to output something like this. This is an example input and an example output. Um, and then you write some code in any language, and then you go to submit code. You select the problem A, which language you have written your code in, paste your code, and paste your code, submit your code, and then your code will run in some backend in the code forces website, and they will check if it is accepted or there is a wrong answer. And if it is accepted, you can move on to the next problem, and if it is not, it is either your choice. You spend more time on on this current problem, or you can move on to the next problem. That And at the end of the contest, you have about 2 to 3 hours normally in a contest. At the end, you get a standing. And in yesterday's contest, this guy Keeson 48 was like the first. And why was he the first? Shit, he he's first, but it took him 8 minutes to do the first problem, and it also took me 8 minutes to do the first problem. So that is cool. And he did the second problem in 7 minutes. And these times that are shown here, they are from the start of the contest. So this means that from the start, when the contest started at 8 o'clock, 8 p.m., 5 minutes, it took him 8 minutes after that point to submit the right solution for problem A, and 7 minutes from that same point to do problem number B. So from the start of the contest, this guy did problem B in 7 minutes, and then after 1 minute of submitting the correct answer for B, he submitted the correct answer for A, problem A, and then after that, 3 minutes later, he submitted the right answer for C, and like that. And that is why he has higher points. And yep, and your performance describes how your rating will be changed. For me, my rating is right now 1300, and in my first contest I got 421 rating and stuff like that. And according to your performance, your rating goes up or down. And 2000 only there are only about 1% people in the whole world who have a rating of 2000, and that is where I want to get rating of 2000. That is what I want to do. On solving 1100 rated problems, what should I do? Solve 1100 rated problems. Like, that's it. Just keep solving problems and keep solving difficult and more difficult problems. What's the use of these contests to test yourself and change your rating and see? What's the use of these problems? You get better at DSA and problem solving in general. And if you are a good competitive programmer, that is, if you are good at solving at these contests, then it helps in general programming also, because in general programming you also have to study and solve problems, build stuff, and for that this thing helps you. Like maths helps you in thinking logically in general. The same way this thing helps you, and in this the skill that you are specifically improving is called DSA, data structure and algorithms. And yeah, it helps you in general logical thinking. How to reach people, from where you choose problems. I choose problems from this thing. This is a sheet CP31, and it has problems at different levels: 800 level problems, 900, 1000, 1100, 1200. Currently I'm at 1200, and today I will complete these 4 problems, and I guess after that I will be solving neat code problems, because I want to get better at DSA, which would give me tools to solve these CP problems faster. And CP means competitive programming. And welcome. Hey bro, I'm new in programming. Where should I start from? Interest. Okay, so can you suggest from where I should start, C or Python or Java? Yes, I can. CS 50. This is what I recommend to anyone who is starting to learn and get into programming. This is what I did when I started programming. And if I'm struggling to see the solution, then it is when you are struggling to solve a problem, you can generally tell what part of the problem that you are struggling it at. If you cannot even understand what the problem is, then maybe you should look at the editorial. But if you are just unable to figure out a very specific thing in the problem, and you understand the problem, and you understand what you want from the problem, then you can spend time and discover or invent the algorithm. But if it is taking you more than 30-40 minutes, then maybe you can look at the editorial and try to implement the solution after reading that. And yeah, that's it. You can go and take this course if you are beginning to do programming. CS 50 it is called. Yes sir. And yep, Ritik brother with beluga photo can take CS 50. It is a free course by Harvard University. Its lectures are on YouTube, and it also has a lot of problems after every lecture. It is 12-week long, one lecture every week and a set of problems for every week. And yeah, that's how you do it. And at the end, you will get a certificate. But more than that, the important thing is you will understand programming, the basics at least. And no, I'm not working. I'm in my 3rd year right now in college. And now to the next problem. And this is the one that took me more time. Like, look at this. Look at this. Wrong, 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 wrong. And then I got it correct. Yeah, shit. What are the tags? Greedy and games. Okay. So in this problem, let me read it first. Many has logged Hamid in a 1 by n grid. Initially, some cells of the grid contain walls and the rest are empty. And Hamid is in an empty cell, of course, because there is no wall. In each day, the following events happen in order. Mani selects an empty cell and builds a wall in that cell. Note that he cannot build a wall in the cell which Hamid currently is at, and Hamid selects a direction left or right. Then, if there is no wall in that direction, he will escape the grid. Otherwise, he will move to the nearest wall in that direction and destroy the wall. Destroy that wall. Hamid is at the position of the destroyed wall after this. Here is an example. Okay, so in this question, we have a big grid, one-dimensional grid, and we have a guy named Hamid, and every day there is another guy named, I guess, what is the name of the other guy? Mani. It went away. And yeah, we have a grid, one-dimensional grid, and at some places we have walls, and we have our guy Hamid at some place. And every day, Mani chooses one cell and creates a wall there. And Mani can choose any of these cells except the cells where Hamid is at. So Mani can choose any of these cells. And after the wall is built, Hamid can choose one direction, either left or right. And if there is no wall in that direction, Hamid will go out of the grid and will escape from this grid. But if there is a wall, like in this case, we have a wall in this cell, then Hamid will destroy that wall and occupy that new cell. And it is also like this. If Hamid is initially here and we had, let's say, a wall here, this is a wall here, and then Mani created a wall here. Then let's say Hamid chooses this direction, then the closest wall is this, and Hamid will destroy this wall and will occupy this position. And yeah, those are the rules. And then Hamid wants to get out of the prison as fast as possible, and Mani does not want that to happen. And the main thing that you have to realize in this is that initially, if Hamid is at any point of the corner, then Mani cannot create a wall here since Hamid is here, and Hamid can choose this direction to get out. And if he is on the other side, he can choose this direction to get out, and that would take him one day to get out. But and also if we have a grid and we have no walls and Hamid is here, then Mani does not matter which cell Mani picks, either here or any other cell. One direction would always be open and Hamid can get out. So in these two cases, when there is no wall or when Hamid is at one of the corner positions, you can get out in one day. But in a general situation, when this is not the case, in a general situation, what matters is this. Let's say Hamid is here. Then what matters is, first of all, Hamid's location, and second of all, the last wall to the left of Hamid. That is the last wall to the most right. Like if we have a wall here, they do not matter. Only this walls that is closest to Hamid matters. And the same thing goes here. the closest wall to the right of Hamid, which is closest to Hamid, matters. And given these three numbers, we can figure out the correct answer. And how is that? Let's say in this side, we have the wall at position 3, Hamid is at 4th position, and here this wall is at 6th position. So in the next turn, Mani has two options. Mani has to see that mm, whichever wall is closest to the exit. On the right, Mani has two positions, and on the right, Mani will have to the closest wall to Hamid is only 2 blocks away on the right, and the closest wall to Hamid on the left is 3 blocks away from Hamid. So Mani would not like Hamid to go here. Therefore, Mani will create a wall here, and that is like fixed because if Mani were to create any wall here, then Hamid would go here to the closest side and get out in least amount of days as he can. So this choice is fixed. Mani would choose a wall which is closer to exit, and then given that choice made by Hamid, given that choice made by Mani, Hamid has now two options. This was the original wall on the left, and this is the wall created by Mani. And now Hamid has two options. Either he goes left or he goes right. And if he goes left, he would have to cross three walls. And if he goes right, he would have to cross three walls. So that is the same. And so he can, in this case, go out through any of the side and keep choosing that side again. Let's say he chooses this, then he would destroy this wall and occupy this place. And then let's say Mani chooses this block to create a wall, then Hamid would choose this side again and destroy this and be here. And then let's say Mani creates a wall here again, and then Hamid would choose this again, destroy the wall, be here, and then the next day he will go out. So it will take him 3 days to destroy all of these walls one by day and one day to get out. So in total, number of walls plus one, which is 4. And in my solution, that is what I check. I first taken the n, which is the size of the grid. I taken n, and then I taken k, which represents Mani's position, and then I taken the grid itself. And then I check, is Mani at the first position or at the last? And if he is Hamid at the first position or at the last? And if he is at any of these positions, then he can get out in one day. Else, if he is not, then I'm doing this left -1. This represents initially I have -1. The number of walls that the first wall on the left is at -1, and the first wall on right is at nth position because this is 0 indexed. So so n represents index outside of the array, and that would be n. And then I go through the grid and I see if I is less than k-1. That is, currently I am at a place that is to the left of Hamid, and this place is a wall which is represented by hash. Then I put left equal to this index where the wall is. And then if I is to the right of Hamid, if currently I'm at to the right of Hamid and this place is a wall, then I put right equal to that index and then break. Therefore, I will be getting the first instance to the right of Hamid, which has a wall. And then if left is not equal to -1, that is, I have seen a wall in the sequence that is to the left of Hamid, or I have seen a wall to the right of Hamid, to Hamid's right. If any of these is true, then on the left, the closest wall is left plus 1, and on the right, the closest, the number of walls would be n minus 1. If I have a wall on the left at index 0, that would mean I have one wall. So that is why I'm doing n plus left plus 1, because that is the amount of walls that he would have to go, Hamid would have to go through to get out. And to the right, if I have, let's say, a wall on n minus 1, then subtracting n minus 1 from n gives me 1, and that is true. I have only one wall. So if I have less walls on the left than on the right, then Mani would like to create a wall just to the left of Hamid, so that Hamid cannot go to the left wall directly. Therefore, left changes, the number of walls on left changes from left plus 1 to k, which represents the number of walls on the left. And now k represents the number of days it would take to get out of the grid if Hamid chooses to go to his left. And this n minus 1 plus n minus right plus 1, n minus right represents the number of walls, and n minus right plus 1 represents the number of days it takes Hamid to get out. Now, if he can get out from the left in lower number of days, then C out k, and if not, then n minus right plus 1. And in this case, when initially, from the initial thing, there are lower number of walls on the right, then Mani would create a wall just right to Hamid, and on the left, it would take me left Hamid, left plus 2 days to get out, and if he chooses to go right, it would take him n minus k plus 1 days to get out. And depending on whichever is smaller, he gets out in just that thing. And else, that is, if there is no wall to the left or right, then he can get out in one day. And that is cool. But the non-cool part about it is that it took me over an hour to get this right. Yep, which is very bad. And that is it for yesterday's questions. No, I do not work. I'm not in an IIT. You are working hard. Thank you for that. Sketches by Piyush and Dev. But I'm not in an IIT. I just go to a tier 3 local college near my house. And yep, I did this, but I'm not very proud of my performance with this second question. And now I would like to do these questions. There are only 4 questions remaining at 1200 rating in CP31. So I will first of all finish these 4 questions, and then I will move on to do these neat code questions. And like I said, my format for solving these has changed. While I'm solving a question, I will have a stopwatch on in one tab, and I will not interact with the chat at all. I will be just like dead in, and to indicate that I have added this thing, you see, problem solving right now will interact just after this. So while I'm solving problem, I will have this on and normally off. This is cool. This looks cool, really cool. And now I'm gonna start solving the problem. For that, let me go to the correct session. Start in your whim. And I have the tag up, that is cool. I'll drink water. Okay. Um, Okay. Mhm. Mhm. So it has been 37 minutes and OSC language for lead code. Hello, dears, it has been 37 minutes and I guess now I can 38 minutes is a very long time. Look at the solution for this. I understand the problem and I am getting the right answer for at least three, but there is a edge case which I understand, but I do not know how to solve. So I will have to look at the solution to do this because I do not have to invent things. My goal is to study and understand them. That is the goal. And B. Wait, why are these like this? B tutorial. And hi, bro. Hello. Let's take each number modulo m. Let's take each number modulo m. So if my m is 8 and my current number is 7, I would have 7. And if my shit, I am stupid. Yes, shit, this is what I should have done. And then I would be looking at how shit that would avoid this part. This when I'm doing need plus k. Yeah, okay, so this was stupid. This was overly complicated, more complicated than I needed it to be. And this would be avoidable if I did something like this here. Not this, and then x modulo modulo equals k. Shit, this is cool. And okay, I will not look at the rest of the solution and I will try to figure it out on my own. Okay, now this actually makes it easier. Okay, now I can have a map which does the bidding for me. At the end, I will output the answer and I can have. Do I need to sort? Nope, I can use a map instead. MP and for auto x in a mp dot mp x plus plus. I have the count for all of these numbers and for int I equals 1. For 0, I do not care. I can put all of them in one place. I equals 1 till I less than k and I plus plus. Uh, if mp is 0, if there is are perfect multiples of k, then answer increases by 1, and then I will be looking at that. And okay, so yes, here this thing, and okay, and other is k minus I, and I need to see how many of this I there are and how many of other, which I can promptly rename to j there are. And okay, minimum plus 1 and int mn equals minimum of I, minimum of their count MPI and MPJ, and in MX equals maximum of MPI and MPJ. And now that I have that minimum and maximum, if maximum is greater than minimum, okay, then the answer would be if mx greater than mn, if mx greater than mn. If mx greater than mn, either maximum is lower than mn or not, and also I need to see that this exists. So if MPI, if it exists, only then do this and go. And I also do not want duplicates. I can go, yeah, this is fine, but I do not want duplicates, so I will put them equal to 0. Yes, later, after when I'm done with them. So I know that this exists and j k, okay, and if mpj, if the other side exists, only then do all of this. Otherwise, answer plus equals one group for MPI, count of MPI, and MPI is not a multiple of k, that I know for sure. And now at this point, I know both exist on both the sides, and there is a minimum and there is a maximum. And if the maximum is greater than or equal to the minimum, then this would cover answer plus equals 1 and mx minus equals mn plus 1, and then answer plus equals, I can do this, answer plus equals here I would have minimum, and here answer plus equals the new value of mx for every remaining mx count. Okay, let's see. Wrong answer, that is cool. I say here 5 and here I say 10. Why do I say that? Okay. Mhm. Then, okay. What is the array? Yep. This is the array, and for 1, I will see that the count is 3, and for 7, that is the other thing that I need at the opposite end. The answer, it is 7, and 7 is appearing only once. So 7 minimum would be equal to 1 and maximum would be equal to 3. And through this, through 1 minimum, I can create minimum plus 1. I can cover minimum plus 1 maximums. So these two ones and this would make one group, and this would have to make a separate group of its own. So that would make the answer to 1. See how answer. Answer became 3 when this was, let's also print I. Okay. When I was 1, my answer increased to 3 because it first covered this 0. Okay. And then I was 2, my answer was increased by 1 because I could have 2 with this 6. Makes sense. And then when I went to 6, yeah, I am double counting. I'm double counting. After I am done with both of these, I can put MPI equals 0. And after I am done with this, MPJ equals 0. Putting MPJ equals 0 is also important. And so let's see, and wrong answer. Interesting. What am I doing wrong now? When it was when I was 1, answer became 3. When I was 2, answer increased by 1 because of the 6. When then I was looking at 4, answer increased by 1 to be equal to 5. And this one, the answer is 6. Okay, it became 5. And then why did I output 7? But this is the answer. When it was 4, why did the answer become 6? Because makes sense because it is equal. Okay, for 4, I equals 4, and also j equals 4, and for both of them count is 2. Minimum will equal to maximum. So this is false, and answer will be increased by mn. That is stupid. Answer should be increased by 1 because I will make one group. And that gives me the right answer. And will it work? Yeah, it should work. Submit. Let's see. Okay, accepted. That is cool. And yep, that is cool, accepted. And the thing that I needed to know was this modulo shit. I just read this line from the solution, and then I was able to write the solution on my own. So what was lacking in my understanding, uh, which because of which I was unable to come up with this. It was that I want remainder. We are talking here about divisibility. So in divisibility, remainder is the thing. Modulo, I should have thought about modulo because we are talking about divisibility and stuff like that. Yeah. So this, I said 40, I guess it was 48 minutes, 38, 40 minutes unable. Here I'm keeping track of how much time it took me originally to do these questions so that when I do them for the next time, I can compare how much I have grown. And now I will move on to the next question. And I will move on to the next question. And yes, problem solving mode will interact after this. And I have stuff ready. Go. Okay. This is maths. Seems correct. And wow. Let's see how that goes. Accepted. That is cool. That is cool. It took me 23 minutes. Let's say 23 minutes is y- uh yeah, 23 minutes is not that good. I could have done better. But yeah. And now I will try to explain what I did and what I could have done better. And yeah, again, the same thing about implementation, about having first I have to construct my thought thoroughly and then implement it in a way that is cool and I can remove this thing. Problem solving mode is off. Well, at least I got it right in first try. That is cool. So in this question, we have two cats and a bunch of napping places that they can nap at, right? Like this. And these places have been given names. 1, 2, 3. Let's go all the way. 4, 5, 6, 7, 8, 9, 10, 11, and 12. And we have cat A and cat B. Cat A starts from the nth napping place and cat B starts from the first napping place. And after every hour, cat B moves like this. In a cyclic manner, moves to the next couch like this. And cat A, after every hour, moves like this in the opposite direction. And at some point, they will merge. At some point, there will be a conflict. But in a case when the number of couches, when the number of couch is even, then we will never get a conflict, because let's say initially cat B is here and cat A is here, then B goes to here, A is here, and then B is here, then A is here, B is here, A is then here, B is then here, A is here, and now on the next tower B will be here and A will be here, and then A wants to get here and B wants to get here, and there is no conflict. And so cat A will be here and B will be here, and now they are as they were initially, side by side, moving in opposite directions. And since we didn't get a conflict at this intersection place, we will never get a conflict. And when n is even, therefore, we simply have to output the place, the number of the couch where B would be if A didn't exist. A does not matter. A in this case does not matter. So that is what I'm checking. If remainder with 2 equals 0, if there is no remainder with 2, then int rem is remainder when dividing the number of couches with k, which would give me that, let's say, if n equals 5 and k equals 7, and there are 5 couches and I move from couch to couch every hour, and I do this for 7th hour, for 7 times. And so at the first hour, I will be at couch 1, at the second hour, I will be at couch 2, at third, I will be at couch 3, at fourth hour, I will be at couch 4, and at fifth hour, I will be at couch 5, but at sixth hour, I will be at couch 1. So if I take remainder of k with n, for this I will get 1, for this I will get 2, for this I will get 3, for this I will get 4, and for this I will get 0, and then for 6 I will get 1. So when remainder is not equal to 0, I can just output whatever the remainder is, but when it is equal to 0, then I have to output value of n, and that is what I'm doing. I'm taking the remainder here, and if there is a remainder, then output remainder. Otherwise, if remainder is 0, then output n. And in the second case, when there are odd number of couches, let's say I have 5 couches, then there will be a conflict. And cat, let's say this in this couch is couch number 1, and this is 5, this is 4, 3, 2, and cat B begins here at hour 1, cat B is here, and at hour 1 cat A is here. Then at hour 2 cat A will be here, and cat B will be here. Then at hour 3 we will see a conflict, because at hour 3 cat A, wrong color, at hour B cat A will come from here to here, and cat B would also like to come, but this place has been taken, so it would have to go there instead. And we can treat this as if cat B went to this place and then went to this place, and we can treat this as by increasing the number of hours by 1. Instead of saying that at the second hour cat B would be here, making it more complicated, we could say that cat B is here at the third hour. That is like makes sense, right? And now cat A is here and cat B is here.